Hello and welcome. This is Project 4 Advances, Innovations, and Trends for Dr. Hassan Rashidi's ME 3210 Design and Manufacturing course at Georgia Tech. We will be presenting today on exactly that, advances, innovations, and trends in design and manufacturing that we really liked and been captivated over throughout the semester. So we'll go ahead and hop right into it. Our first topic is binder jet printing. This is one that I really enjoyed, where it's essentially an additive manufacturing process where you'll have a print head and it deposits liquid binder into a layer of powder particles, and that builds the parts because essentially you're allowing that binder to bring in those powder particles and it builds parts on top of it. This is really widely used in ceramics, aerospace, and more precise form parts. Think your scale models, toys of that sort, where it has to be a very precisely formed figure. It's really important, and I find it really captivating because it allows for really high production speed and the ability to mass produce large volumes of whatever parts. So that's where you can go ahead and essentially use it for creating really large volumes. And it makes production of intricate designs a much more simple process and can really spread that quite a bit. Capabilities and limitations is extremely fast, extremely precise, and you can use it in very high production outputs. Sometimes the surface quality is not great. That's one of the limitations, along with size limitations. You know, you're restricted by the area where you can actually insert that powder. So that can happen. And then also sometimes parts can come out porous, which is obviously not wanted. But these are all very minor issues in terms of the benefit that it actually can provide. Topic 2 was nanoscale manufacturing. This was something that I found really, really interesting, where essentially you can, or it's manufacturing that occurs at incredibly small scales, so 100 nanometers or less. And I think human hair is about 100,000 nanometers. So incredibly small manufacturing that you can use for essentially lubricant coatings, DNA-based structures, polymers, and nanomachines. You can see the infographic on the right basically on how it works. And it's really important because you can really increase the quality, strength, and ability of especially digital devices. If you've ever opened up a computer, looked at a motherboard or anything, there are all these extremely small features on it, and that is what nanoscale manufacturing can really help speed up the process with. And it's really evolving and revolutionizing several different very important manufacturing sectors. Capabilities, it can work with nanomaterials, something that really as a species we weren't really able to do very much of before. Improves strength, flexibility, durability, and conductivity of materials. Limitations, you are dependent on your data inputs. So your sensor qualities, your machine quality, and it can be expensive. As with any very new technology, that expense will come down over time, but at the moment is still a fairly expensive and new area of technology. Topic 3 is IoT. So this is industrial Internet of Things, which is essentially a collection of autonomous devices connected through the internet to drive industrial activities, specifically in this application. So a lot of the applications you can use it for are things like predictive maintenance, quality control, safety, smart factories, which we'll get into a little bit later. But it's very important and very interesting to see just how everything can link together through utilizing modern technology and the internet. And it can reduce maintenance costs and downtimes by essentially optimizing the use of how you're, optimizing your use of technology within an industrial setting. Capabilities, it can improve efficiency, once again, predictive maintenance, supply chain management, cost savings, and improved quality of parts. There are some privacy concerns, as with anything with technology, data breaches, device hacking, etc. Maintaining connectivity is very important here, and then specifically skilled labor is needed. Lean manufacturing is my fourth and last one, where it's essentially a system for reducing wasteful excess. So optimizing that manufacturing process, making sure that you're not doing anything outside of exactly what you need to. Some of the applications include large-scale manufacturing. Think car factories. This was initially a system founded by Toyota, so this is something where it's really used, especially in assembly line manufacturing. It's very important because it's a total optimization of the manufacturing process. So think of all of that fat and that excess being trimmed away, and you're really left down with the manufacturing process. Your capabilities, quality, improves the quality, reduces the waste. Sustainability is definitely increased because you're not wasting excess parts, but you are more dependent on suppliers, and it can increase your processing costs just simply because of you're needing only the parts that you need. And so when anything goes wrong, you're driven a little bit towards needing additional parts and supplies.
A minimum viable product is a version of a product that includes only the essential features necessary to satisfy early customers and provide feedback for future development. Its applications include startup development by quickly testing a business idea with minimal resources to gauge market demand. Also, it benefits market research by testing how a new idea resonates with potential customers before full-scale production. This leads us to its importance. Building a full product without validation can be expensive and risky. An MVP focuses on essential features, keeping costs low. It also facilitates iterative development by setting the stage for continuous improvement based on data-driven decisions. This topic leads to better design and manufacturing of products by reducing design flaws early. Early identification reduces the cost and effort of redesigns, ensuring the final product is more robust and user-friendly. Its capabilities include market validation by determining whether there is a market demand for the product or idea, customer feedback with collecting real user feedback on functionality, design, and usability, and risk mitigation by identifying potential issues early. Its limitations, however, include incomplete user experience, limited market perception, and competitive risks with other companies potentially taking ideas from the MVP. Next is 3D metrology. 3D metrology is the science of measuring the geometry, dimensions, and physical properties of objects in 3 dimensions. It plays a critical role in quality control, manufacturing, engineering, and research. Its applications include quality control by ensuring manufactured components meet dimensional tolerances and design specifications. It also allows for reverse engineering, making it easier to replicate or redesign models. 3D metrology is important because modern products often require tight tolerances to function effectively, especially in industries like aerospace, automotive, and medical. Also, it improves product quality by helping identify and eliminate defects in the manufacturing process. This can help design and manufacture better products, since it allows for precision design, which eliminates discrepancies in the mass product and manufacturing of the product, allowing for rapid iterations. Its capabilities include high precision and accuracy, non-destructive testing, and 3D visualization. Its limitations, however, are high costs, high skill requirements, and its inability to access internal features of the product itself. Next is lights out manufacturing. Lights out manufacturing refers to fully automated production systems that require minimal or no human intervention. Its applications include the medical devices field and 3D printing, where human intervention is not needed and the process can be done after hours. Lights out manufacturing is very important because it replaces manual labor with automated systems, minimizing workforce requirements. It also minimizes human involvement in dangerous or repetitive tasks, reducing workplace hazards. It results in better design and manufacturing of products since the production is more consistent by eliminating human factors. Its capabilities include the fact that machines operate without breaks, enabling uninterrupted production and maximizing the output. Also, reduced labor costs and the process being able to operate in environments without lighting, heating, or cooling lowers energy usage and costs. Its limitations, however, include cybersecurity risks, ethical concerns of human labor being replaced, and high costs of equipment to keep the process running.
We will now be getting into our eighth topic, gravity casting systems. So what gravity casting systems is a manufacturing process where molten material is poured into a mold and is purely formed strictly by gravity, and oftentimes offers high precision and good surface finishes for medium to high volume production. And what's a great thing about this process is that it's a almost blind casting system where material that's left on top of the vent or the open riser or any other parts of the cast can be reused and remelted in high volumes and then repoured once again, offering somewhat reduced waste. So applications of of this casting system is that it's used in many industries, but primarily it's used in automotive and consumer goods. The importance of gravity casting lies within its cost effectiveness for high volume production, along with its ability to achieve good dimensions and surface finishes, and it supports a versatile types of materials. However, with all casting methods, there are some capabilities and limitations. Gravity casting excels in producing medium to large size components with consistent quality, while permanent molds are used. It's an excellent choice for application requiring strength, durability, and precision. However, in some of the limitations, gravity-driven filling restricts design complexity, as not all pieces and components can be filled strictly by gravity. Some surface quality and slower production rates make this not the best or ideal choice for high precision, singular, one-off parts. Now we'll get into our ninth topic, abrasive machining process. This abrasive machining process is a technique that uses tools embedded with abrasive grains to grind and cut out or polish a material. Now, this has many applications and is especially used for high precision parts such as engine parts. As you can see in this little diagram, both the material and the abrasive grains will ultimately be reduced or damaged in the process. However, these abrasive grains under the binding coat can last for a while and leaves the material with an amazing smooth polish finish. The importance of abrasive machining is its ability to handle extremely hard and brittle materials, like ceramics and superalloys, with amazing precision. It's crucial for industries that require tight tolerances and superior surface finishes. Now, along with all types of smoothing processes and finishers, there's some capabilities and limitations. This process is capable of machining intricate shapes with high precision and combining multiple steps like cutting and polishing, such as shown right here. However, some limitations is that abrasive tools ultimately will wear out faster, leading higher operational costs. It is also energy intensive and unsuitable for machining soft and ductile materials, such as aluminum, which will inadvertently clog the abrasive or make the abrasive be smoothed out without actually finishing or polishing the material itself. Finally, the 10th topic that we will be discussing today is destructive testing techniques. Destructive testing techniques physically involve the breakdown or damaging of materials or components to evaluate its properties, performances, or failure modes. Now, this is used widely in construction and aerospace, as these are two items where ultimately a destructiveness or a mislap on testing can result in lives being lost. In construction, it is crucial to be able to test this destructive testing techniques as it allows us to simulate real life applications under controlled environment. And the same goes for aerospace. The importance of destructive testing lies within its ability to ensure safety and reliability of materials, provides key insights into material mechanical properties, and validates compliances within industry standards. Now, while destructive testing techniques might be one of the best ways to test if a material or a product is safe, it also has its capabilities and limitations. Its capabilities include measuring material performances under extreme conditions, identifying failure modes, and supporting the development of new materials. For example, tensile testing can reveal how much of a load of a material can withstand before breaking, such as on an airplane. However, the destructive measures and meanings oftentimes have some limitations. The test specimen is completely destroyed and cannot be rebuilt, making it more expensive for material costs. It's also time-consuming and unsuitable for finished products intended for customers. However, regardless of these limitations, it's extremely important in everyday life.
And as always, here is the resources that we used for this project, and just a disclaimer that this is for educational purposes only.